So before we start doing any questions, it's important that I go through how I assign oxidation numbers. There are multiple little processes that one can follow to assign oxidation numbers for atoms and compounds. A lot of those have, in my opinion, redundant things you have to memorize. So I'm going to do it my way, and hopefully that will follow okay for you. So anyway, the first rule is each type of atom in a species gets an oxidation number. Now, the way this calculates it, you get the average oxidation number. There are some organic compounds, there are some transition metal compounds where the same type of atom has different oxidation numbers. While this process doesn't separate those, it just gives you the average. Not actually that big a deal for the A level. Rule number 2 is one that encompasses several rules in other processes. Simply, the total oxidation number is the charge on the species. So if you've got a monatomic anion, the oxidation number is just its charge. If you've got a monatomic cation, the oxidation number is just its charge. And if you have an element which has charge of 0 and the same type of atom in there, then by definition the oxidation number of the atoms in that element are 0. Okay, so rule number 2 takes care of several rules in other processes. Still can't assign oxidation numbers, then do it using chemical knowledge, and that's really important to think through it. Okay, in the order, first of all, metal cations have the oxidation number equal to the charge on the cation. Now that doesn't necessarily help with transition metals, but it definitely helps for main group, the S and the P block metals. Alkaline metals, always +1. Alkaline earth metals, always +2. Aluminium and gallium, always +3. Now, of course, even with some of those P block metals, like for example tin and especially lead, you have to be very careful because of that inert S effect. So lead can be +2 or +4, usually +2. Tin can be +2 or +4. So you have to there look at the context as you would with transition metal cations. But the ones listed, alkaline metals, alkaline earth metals, aluminium and gallium, pretty straightforward to be able to tell what their oxidation number is. Now those are the immediately assignable positive oxidation numbers. The next one in the list is an immediately assignable negative oxidation number. If you have fluorine in a compound, it's -1, end of. Then you get to hydrogen, which can be made into -1 by alkaline metals, alkaline earth metals, but otherwise in a compound it's going to be +1. Can't be +2 because it only has one electron it can lose, and it can't be more negative than -1 because -1 takes it up to the helium electron configuration. Now at that point, if you've still got oxygen unassigned, you can say it's going to be -2. Now at that point, my assignment stops, because unlike a lot of other processes, because at this point you can say, well, most of the time you've got all your numbers assigned. If you haven't got all the numbers assigned, well then at that point you say, well, whichever is the most electronegative atom left, let's give that the negative charge that it would want, because presumably it's a non-metal, so therefore would want to make anions, and then that should pretty much take care of it. And as we'll go through, we'll see a couple of examples in which you have to get to step 5. Anyway, longer possibly than I should have done going through the process, but now I've done this, I can go rather quickly through all of the times in which we have to assign oxidation numbers in the rest of the worksheet, which of course is quite a lot.